And morning, everyone. So I'm Iain Donnison from Aberystwyth University, and as Patricia was saying, I've been leading the resources topic. I'm not going to tell you all the things we've been doing. My fantastic colleagues are going to be telling you what they've been doing, and there's three people in particular who've been working. I mean, there's three people in this session, and there's a couple other people in later sessions who've also been working on resources within Supergen, but particularly in, I guess, this first sort of topic area, those who've been those most consistently engaged are all talking this morning. So we have Anita Shepherd, who's was a fellow who was appointed during the project, and she's going to be joining us online from Aberdeen. We've got Naveed Arshad, who's been working with myself at Aberystwyth, and he's also been working with Rebecca Rowe, who's also going to be talking, she's from CEH. And then we've also got an industrial perspective by Neil Harrison, who's from Reheat, and is also a member of the advisory board. So we've got, I guess, the main bit that we've been really working on is this piece about, this challenge about is there enough biomass, will there be enough biomass, and really trying to understand, at a sort of landscape scale, what are the opportunities for producing biomass, and also what are some of those implications, particularly of the land use transitions, and particularly in terms of some of the environmental impacts. So those will be covered, and then also we have that industrial perspective as well. Industrial and sort of policy. So at this point, I think I'm going to introduce Anita. So hopefully the technology is going to be fantastic. So we're connected through to Anita Shepherd. Anita, can you hear us?
Yes, thank you. Hello.
Brilliant. Morning, Anita. So I've just been introducing the session. Hopefully you've been hearing that, and hopefully you're going to tell us about the work you've been doing in your fellowship now.
Yes, thank you.
Wonderful.
Now, how much miscanthus biomass do you think the UK or Europe could grow? Who would buy it, and what are the obstacles in their way? This was the focus of Project Summer, funded by the Supergen Bioenergy and conducted in partnership with the GRACE project field trials. Currently in the UK, miscanthus burning power stations have insufficient feedstock. The process of plant production by rhizome to rhizome propagation is slow, but newly developed seed propagated plants can be produced in greater numbers to scale up bioenergy. These are currently in field trials under the European GRACE project. So using the GRACE field trial measurements, I calibrated a bioenergy model to 3 novel hybrids. This was the production aspect. I determined the biomass, energy potential, and carbon balance of these crops from a production aspect. But from the market aspect, I also planned and conducted a grower survey with a link sent to growers in my industrial partner TerraVesta's newsletter. I collated the responses and employed a postdoc to write up the results for publication, which has just been accepted in GCB Bioenergy. So these photos show my colleague Enrico with the 3 miscanthus hybrids and the current commercial crop growing in autumn in Piacenza, Italy. The first on the left is seeded miscanthus sinensis crossed with sinensis. The second one is the current commercial crop, the rhizome-based miscanthus giganteus. And then we have the seeded miscanthus sacchariflorus tamsinensis, we call Saxin, marketed as Aphrodite, and the rhizome propagated M. Saxin, marketed as Athena. These were all grown on marginal field sites at Truscoed, Wales, Oberlindenhof, Germany, Zagreb, Croatia, and Piacenza, Italy. From previous projects and publications, integrated assessment modelling has proved that projecting the same land area for bioenergy crops, it was the same, global projections for bioenergy crops based on socioeconomics actually showed the same as our conversions of 10% arable and 10% grassland. So in order to satisfy climate scenarios with a restriction of temperature increase to below 2 degrees centigrade. So I continue to use that. The UK results on the left show a maximum of 11 tonnes per hectare biomass between 2020 and 2030, which is the period used for all the modelling. And the 11 tonnes per hectare is the best biomass yield with good water capacity. I have to add, though, that this is a conservative model prediction. They're probably going to be higher. These calibrations are from marginal lands results, and also this is from a third-year plant growth. This is still immature in the UK and temperate climates. Ideally, Grace would like to have seen their field trials for a greater number of years. The grey areas are land constraints for bioenergy, such as rock, national parks, water, etc., from a famous paper by Andrew Lovett. On the right, it shows areas with the highest variability yield due to variable rainfall, or particularly in the west, where there is higher rainfall, there it's more a variability of soils. The UK aggregate total between 2020 and 2030 using the M-Saxin seeded hybrid. It shows a potential biomass in the UK of 5.8 megatons per year, with the highest yield coming from southwest England and Ireland. And surprisingly, maybe Eastern Scotland. Surprisingly, because miscanthus is not currently marketed there, but the model shows it would potentially grow well in this period. And it's currently growing well in gardens, being available from garden centres in Eastern Scotland. European totals, so basically the European area now, based on the 10% arable, 10% grassland conversion minus land constraints, comprises 15.7 megahectares of land, which can produce nearly 90 megatons of biomass a year, potential BECCS of 40 megatons per year, and 1.2 to 1.3 exajoules electrical energy, based on baled miscanthus burnt power stations. The M-Saxin hybrid, the seeded hybrid, had a poor establishment at temperate sites and a good establishment of crop in Italy. So 2 calibrations of this were made. And the calibration from all crops, poor and good, showed a crop yield potential equal with the current commercial crop. Whereas the calibration from the best established crop showed the potential to outperform rhizome propagated plants. The other novel hybrids also showed promise, but M. sinensis has a higher recommended plant intensity, so the crop would be more expensive. And the rhizome propagated M. saxin that had an excellent yield doesn't overcome the problem of slow propagation, but these could be supportive crops too. But the best crop was the one that showed potential is the seeded M. saxin, if well established. And currently their agronomy trials are underway for this crop in the PBC, perennial biocrops for greenhouse gas reduction project. The European biomass distribution does show the highest yields in blue in Central European areas with plentiful rainfall, good soils, and higher temperatures. Viewing biomass on a ranked country basis with different colours for the hybrids, which show similar patterns. At the top plot, biomass is on a tonnes per hectare basis. And I don't know if this plot is a bit small for you to read this, but the highest countries were Switzerland and Ireland. And those gave the highest yields due to higher water availability and good soils, whereas Greece shows the lowest yield due to poorest water availability. However, on an aggregated country basis in the bottom plot of megatons per year, the highest the most influential factor, of course, is land area. And so France, Ukraine, Germany and Poland show the greatest potential for biomass. Now, the top plot here is the gains or losses of soil carbon in megatons per year, aggregated on a country basis. And the greatest loss of carbon was from Ukraine, but this is due to vulnerable, highly organic Chernozem soils. Poland also has organic soils and a greater loss of carbon. But it's better to view a balance of carbon in the lower plot, where carbon is captured in BECCS and then have taken away the CO2 emissions for the soil loss of carbon, farm processes, transport and land use change. And then the countries with the highest balance of carbon gains are France and Germany. And these are followed by Croatia, Italy and the UK. And now I'll just briefly mention findings from our survey of miscanthus growers on benefits, barriers and incentives for the industry. How paper has just been accepted for publication in GCB Bioenergy, written by Rebecca von Helfeld, a postdoc I employed to write up my results, and she did a brilliant job. So the public, so the public can see it online now. You can read it in GCB Bioenergy. Some findings, briefly, are the most practical reason for growing miscanthus was given as a reduced spraying of chemicals. This agrees with my 2019 grower survey, where they cited it reduces spraying near village playgrounds and homes. The practical difficulties with miscanthus, 35% of respondents cited insufficient knowledge of the crop prior to first harvest. The largest obstacle for expansion for the industry, the growers felt, was the cost of roll haulage was prohibitive. This is evidence that a better distribution in the UK certainly is needed, as the industry is predominantly in Eastern England. And the greatest incentive to miscanthus adoption, the growers felt it was a stable basis for farming operations. And most growers preferred an annual planting grant. And so there were a lot of achievements proving home working really does work. I produced a bioenergy model, a grower knowledge database, European projections, and developed a novel light absorption calibration method, eradicating the need for variable leaf area measurement. I produced 3 manuscripts, 2 reports, and the project was extended and funded by the Perennial Biocrops for Greenhouse Gas Reduction project, who used the results in their research. I trained a postdoc, and results were used by the industrial stakeholder, TerraVesta, and there were lots of research dissemination and lots of experience for myself and benefits. So thank you to Supergen Bioenergy. And also, modelling is nothing without field measurements. So thank you to all the GRACE Consortium and Andrew Lovett. Thank you.
For the presentation. And the plan is that we're going to run through the talks and then we're going to have a panel discussion at the end. So hopefully you'll still be with us at the end of the session, Anita, for when we do that discussion. So we now move on to the next speaker, who's Naveed Arshad, who's also going to be telling us about the work that he's been doing through the project in relation to the I guess what we've often referred to as the opportunity mapping for bioenergy. Okay, thank you,
Naveed. Thank you, Iain. Hello, everyone. I'm Naveed. I'm a special modeler in Aberystwyth University. I was a researcher from Resources Topic Group. We have set some sort of tasks or assignments, including deliverables. Sorry, okay, yeah. so including deliverables. That include the first task, which was on assessment of marginal land. And we tried to understand and assess the potential of marginal land, its definition, and what is the classification criteria and management. And the deliverable was a report. And the second task was about soil and climate heterogeneity, which was to understand the local soil and climate heterogeneity on crop performance, to understand the crop performance under future climate scenarios and future smart energy crop agriculture. The third task was modeling ecosystem impacts, and it was about spatial models which will be used to mapping of the effect of varying crop and genotype on ecosystem impacts. So the fourth one was an opportunity maps, which was actually developing using different type of data sets, including yield, climate, soil data, which can allow us to develop opportunity maps for energy crops, and deliverables was set of maps. So starting from the first task, we use to understand what is marginal land, how we identify land as a marginal, how much land is available, and then assessment of marginal land, what is the concept of marginal land, and what is the classification criteria to classify a land as productive and marginal or non-productive, and what are the methods to identify as marginal land, and what is the management opportunities for those type of lands. We use a really good type of information layout, which was about land information system. Land information system is a complete set of information that provide what type of data set available from your land, and what are the different land functions, how you can use these land functions to develop some sort of threshold, including productivity, economic profit, water quality, soil quality, biodiversity, and sustainability. And then you set a criteria, and that criteria is very much important, because that criteria, you use it to classify land based on all the big data set about either land is productive or unproductive, or we can call it marginal. Why we're calling it marginal? Because it can be productive for one type of purpose, but it can be unproductive for other type of purpose. So there's using that type of understanding of from the land information system, we can use it for land use planning, for policy and regulations, and land management, and then land monitoring as well. So these are a few key messages from the report which was published. And it's about the definition of marginal land. It varies worldwide. Marginality is not just based on qualitative factors, but it's based such as land fertility, but also on political drivers and social values as well. So we have identified there are several different qualitative and quantitative approaches, but we identified that a system approach is the best that's being used for agricultural land classification by government, to consider multiple factors which classify marginal land that bring advances for our more robust decision making. And biomass crop that are one of the options, and it's a big debate on that either we can use those lands which can't produce arable crops, but we can have really good type of yield from those type of land, which already being shown by Anita as well. So this is a report which was published in 2021 last year. And moving from this task, we moved to opportunity maps. It was involved the yield data and other genetic improvements to use for crop modeling. And I've used MISCAN4 model, which is a process-based model. And that model requires input data set, including climatic data as well as soil data, and that being used on a farm scale to the regional scale to identify which are the hotspots to grow miscanthus, and how we can use this different type of information to use it to identify where we can grow miscanthus and willow crop. So why have you choose 2 crops? Because it's more promising and is the leading bioenergy crops. And using that information, why have used miscanthus? Because it has around 15 years of lifetime, and its production is 13 to 15 tons of dry matter per hectare per year. And the same with willow, which is 25 to 30 years of lifetime, and it can produce 7 to 10 tons on an average. So how these opportunity maps can help? It can help to make landscape decision making for a long-term strategy development. I use starting from model parameterization and then develop some high-resolution maps for miscanthus and willow, and I did some sort of model validation using yield data from different locations as well as from satellite remote sensing images to identify to remove those outliers in my mapping, and then use filters that was actually the land, different land attributes, and after that it was some sort of ground truthing, but I haven't done and completed that ground truthing. So starting from my first map, you can see on the left side is predicted miscanthus biomass, which is harvestable yield in tons of dry matter per hectare. And the red color shows 0 to 6 tons, which is the lowest yield, and then the dark green color shows the highest yield for miscanthus. And if you're well aware with the UK map, you can see in the south of England, there is more hotspots are in south of Wales and some West Wales. You can see there's a dark green color, and also on the eastern side of England, you can see there is a highest yield is a potential yield which we can achieve. And it has been reported before that there are some sort of around 20 tons yield has been achieved from farm in UK. So this is actually the potential yield which maximum we can get, and it shows the total area, which is actually the overall UK, because miscanthus can grow everywhere, and it can give total biomass, which is a huge 289 megatons per year, although it's not actually, if we move towards more realistic way, then I first have to move what is the minimum acceptable yield that we can achieve from miscanthus, and that's using, I've discussed with TerraVesta, and from colleagues from TerraVesta, they said for break even, our minimum acceptable yield is 6 tons. So less than 6 tons is not economic. So I use that as a filter. So I moved the yield areas which was less than 6 tons. So this map shows, and is also the area has been reduced to 21 million hectares, and also the total biomass has been reduced to 277 megatons per year. After using that, I was moving more towards what is the realistic type of information, how much of the biomass from miscanthus and where it is available. For that, I use different map improvement tools. The first are the primary filters were built-up areas, which include settlements, which include roads, networks as well, and water bodies, rivers and canals, lakes and reservoirs, forests, historical places, including monuments, World Heritage Sites, green spaces, including parks and gardens. So using that information, I developed maps for that, and you can't see those maps clearly, but using that, using that first primary filters, I developed again that miscanthus map, and it shows it can grow on around 18 million hectares, and also total biomass is 242, but still it's too high. And using that primary constraints are primary level. I moved to the second level, which was using protected areas, because some of the land which is being protected because of several other type of purposes, including special protection areas, site of special scientific interest, conservation areas, which is special area of conservation, natural landscape, which is areas of natural outstanding natural beauty, and natural reserves, national parks. So using that secondary level of land constraints, I developed map which shows special protection areas are filtered out, site of special SSSI and SAC, these are all filtered out, but I haven't excluded areas of outstanding natural beauty, because we can grow the crops and miscanthus and other crops on those lands, but for others, they have the other type of uses as well. So it further refined my maps to show that miscanthus can grow on 16 million hectares, and we can get around 224.56 as a potential biomass from those lands. After using that, maybe you have, I was moving towards the tertiary level, which was using agricultural land classification, because we also need land for food purposes as well. So, so there was another suggestion that if we can grow miscanthus crop according to agricultural land classification on grade 3 to grade 5 lands, because grade 1 and grade 2 land is the land which is a really good type of soil, and that can be used and can be dedicated for arable crops. But for the bioenergy crops, it can be used grade 3 to grade 5. Although grade 4 and grade 5 lands are somehow classified as unfavorable or marginal, marginal land. So, and second one was economics. It is economic comparison of energy crops. And third one is special interest by stakeholders of percentage of area for dedicating some areas for forestry, wildlife, and arable crops. So I've used, and this is, I just want to show you very much detailed about England, that the total land, which is around 7 million hectares land, which is available using those primary and secondary level filters, but it can be only 5 million hectares land available to grow miscanthus. On the left side is the land, is a map which shows how much of the land and where the land is available for using primary and secondary constraints at levels. And the right side is where we can grow miscanthus on marginal land. And on the right side also shows that those are not only the marginal, but it also include the grade 3 land as well, which is also being suggested by several industry people. So the possibility is to have 108 megatons per year per hectare per year. Sorry, not per hectare, it's megatons per year yield we can access, we can have. And using these type of very fine resolution maps, there is a really good opportunity to further work on these type of maps to see that how we can identify some sort of hotspot for our industry people to see where they can start their processing units in different locations based on how much of the biomass they can get. Also to identify the farmer's land where we can achieve that high value of miscanthus and other bioenergy crop. Moving from miscanthus map, I have developed map for short rotation coppice willow, and it is also harvestable yield, which can give a yield as a potential yield of 13.5 to around 14 tons per hectare per year. I got some sort of issues last week, which was some sort of technical issues to further refine this map, but modeling has been done. And in the final report, we'll publish that willow maps as well to show that how much of the willow and where we can grow willow crop. But overall, it shows that some of the lands, which is on also those lands are in south of England, as well as in more parts in Wales, which has more potential to grow and which we can achieve higher yield from those land. And quickly, if I can say that there is also a minimum yield, acceptable yield, which is 5 tons per hectare. And if that's being removed, then the maps will be further refined. And these type of miscanthus willow maps that can be very interesting for our industry people as well as for policymakers to make some sort of future long-term planning to deploy bioenergy crops. So how we can deploy future bioenergy crops? So for that, moving from level 1 to level 2 and then to level 3, there are multiple options available, and those options are based on interest by different stakeholders. Some wants to have land which is more dedicated for forestry, some wants to have land more dedicated for arable crops, food crops, and probably some wants to have land which is for special type of scientific interest to be added. But still there is a good potential because the whole mapping exercise is a live document or live type of modeling exercise where it can be further improved with new data set about the climate, about the soil conditions, as well as based on different type of interest by the people. Thank you for listening.
So thanks very much to Naveed for that. And as I say, we'll be having a panel discussion at the end where we'll pick up questions. So the next speaker, as I mentioned, is Neil Harrison from Reheat, who's going to give us more of an industrial and sort of policy perspective. So Neil, please.
Thanks very much, and thanks for the opportunity to speak, which came in on Friday afternoon, I think. So, yeah, there's not many massive kind of deep dives into graphs and things in this talk, but what I've been asked to do is just sort of skim across the top of where the world of forestry is in the UK at the moment, give you some sort of perspectives on that. So, a little bit about me. I spent the last 20 years being paid by people to help them set fire to things. So we work in predominantly in solid biomass. Our business is 25 people, consultants and engineers and sort of support staff. We work in district heating, forestry contracts, sort of consultancy work in the UK and sometimes overseas as well. Based mainly in the north of England, small engineering team in Lincolnshire as well. We've crept a little bit further south, but we work from kind of the Midlands right the way to the north of England for practical engineering projects and consultancy work in some quite funny and faraway places at times as well. And a few of our clients up there. So I've just sort of broken this into two pieces, sort of market signals around sort of demand, where's demand coming from for forestry products at the moment, and then some of the stuff around what sort of supply side pressures and trends that we're seeing at the moment. So growing markets we have, despite the end of the RHI, which was probably the biggest shot in the arm for sort of solid biomass use and sort of wood fuel, that the UK's ever seen. That sort of has ended a couple of years ago now. Particularly on the back of rising fossil fuel prices. It was starting to happen already with sort of COP26, and industry is light years ahead in terms of government, in terms of where they see bioenergy playing a role in sort of decarbonising the UK economy with some really exciting projects, with exciting clients. This market is growing quite steadily, and fossil fuel price hikes have definitely helped with that as well. I literally cannot keep up with what comes into my inbox now. Nor can the rest of the team. So it's really is a technology which is increasing in demand. So much so that, and because of the implications of what's happened in the Ukraine, Europe is about 1 million tonnes short of pellets going into this heating season. UK is going to be about 25,000 tonnes short of pellets for heating uses going into this heating season as well. So there are some major kind of pressures, and they're turning into price pressures. So pellet price in Germany at the moment, the average is around 690 euros a tonne for a bulk delivery of about 6 tonnes. That's pretty much triple what it was about 2 years ago. So huge price pressure starting to happen as a result of no pellets coming out of Russia, and also no sawn timber for sawing in Estonian and Latvian sawmills coming out of Russia either as well. So there's less co-products. So overall, big demand rise. Everyone tries to get off Russian gas and tries to get on something sustainable, but that sustainable thing from bioenergy is not there. So all sorts of interesting stuff happening in what's actually a market which is showing a lot of growth. We're also seeing a lot of interest, and I don't think there's a day goes by where I don't get some sort of newsletter from the US or New Zealand or something around sustainable aviation fuel, all sorts of different conversion routes from different feedstocks for that, but there's some interesting stuff happening with trees in that market, so that is going to start to draw more material in from forests in the UK and overseas as well for turning into sustainable aviation fuel. So that's an emerging market, very much so at the moment. The Swedes, as you might imagine, from a country that is 70% trees, are doing a lot of work around other things they can substitute fossil fuels for. So there's quite a lot of work going on in bioasphalt, all the kind of weird things I have friends that do. I have a friend who owns a tar plant. He's looked at plastic recycling into it. It doesn't really work that well. And he's now exploring this as an opportunity as well, which is sort of bioasphalt from processing trees in all sorts of interesting ways. So that's an emerging market. We're not going to stop needing roads anytime soon. Biochar, lots of interest in this. That's sort of scaling up. There's lots of different routes to sort of deliver biochar to markets and lots of potential markets it can go into, mainly agriculture. But this is something, again, which is, this is a market which has its eye on our trees. Biochemicals, again, all sorts of different chemicals can be derived from trees. It's a really interesting starting point for lots of people. There's lots and lots of research. I'm sure you'll be far more aware of it than I am, those of you sort of in academic circles. All sorts of interesting things. So lots of other people with their eye on our trees. Plastic replacement. That's replacing, well, there's lots more stuff being done with card and paper in terms of packaging that we had sort of started to do with plastic, and are now the pendulum swung back the other way to using paper and card products, but also displacing stuff that was always done with plastic. So, there's all sorts of things like Johnny Walker Whiskey did their first ever paper bottle to replace glass as well as plastic. So there's all sorts of people eyeing woody feedstocks to turn into paper and pulp products to displace stuff that is more carbon intensive. So that market's got our eye on our trees as well. Back to more traditional markets, this is just from 7 days ago now, because I dropped that slide in last night. In the Independent, timber cities could save 1 billion tonnes of emissions by 2100 or 2100, however you say that. It's too far away for me to care too much. But lots of people eyeing construction timber and more timber into construction, locks that carbon up for a long period of time. Some quite interesting folk I follow on Twitter. They're always tweeting pictures of sort of medieval doors saying, this is carbon that's been locked up for 600 years. I'm not sure your average Barrett house could be expected to last for 600 years. But when you're making stuff out of wood and you're locking that timber up, you're locking carbon up in there. So lots of drives towards displacing concrete, steel, and other sort of carbon-intensive products by locking it up in timber in construction. So they're all the people who are keeping an eye on our wood and asking for wood in ever greater amounts. Bear in mind the UK, I think, is 3rd or 4th lowest forest cover in Europe after, I think, the Netherlands and Belgium are usually in there, and then places like sort of Malta and things like that. So we have very, very low forest cover. It's only around 13% of our land area. You contrast that with Sweden, that's about 70%. So it is very much a finite resource, which has spurred people into action. So if you recall the 2019 election campaign, I can't remember which one that was, we've had that many lately, but it became a kind of, I won't use the term I want to use, but kind of a competition between different political parties. Who could plant the most trees? It was kind of, we're going to plant 1 billion trees. No, it's 2 billion. It became like a pointless bidding war of something that could never and would never ever happen, but it kind of captured the attention of the media and hopefully of the electorate as well. So who can plant the most trees? With absolutely no thought about why those trees were being planted, where they were planted, who would plant them. Huge workforce shortages in the forestry sector, which has been something I've been aware of for the last 20 years. They haven't gone away. So it's kind of bidding war in tree planting. It's great. Why is that important that we have more trees? Well, this is a graph which demonstrates where we sit in terms of our timber imports, which is the second line from the top there. The dotted line, the grey is our apparent consumption, and the blue, the sort of darker purple line, which is our production of timber from UK forests. We are the world's second largest importer of timber and timber products in the UK. we have a very long way to go before we can start to put our own material into all these different new, exciting, emerging markets in any kind of meaningful volume. What's the timber industry done since the last sort of 30 years or so? Well, softwood deliveries, this is a kind of measure of the amount of coniferous commercial timber which has been harvested in the UK and gone into the various different markets that we have. It's kind of plateaued over the last sort of 10 years or so. There's only so much that can come out of our forests on a sustainable basis before you start to sort of decrease the overall forest area, and also kind of workforce limitations and sort of uncertainties in the economy mean that people aren't making massive investments in the machinery and the skills and things. So there's a number of sort of naturally sort of suppressing market factors on the softwood, the market, which is where most of our commercial timber comes from. So we're at about 10 million green tonnes a year at the moment. We've been bouncing along at that kind of figure for most of the last decade. Hardwood deliveries, slightly different picture. We don't do anything like as much hardwood. We don't use hardwood for much. It's not really used in sort of run-of-the-mill construction. It's sort of, somebody wants some oak beams for a fancy extension or something, that's great, but not everybody does that. We tend to want engineered forest products, or we want softwood timber, which is properly graded and used in construction. This stuff tends to be not commercially managed. It tends to be not particularly good quality. So the trees are difficult to harvest with any kind of sort of mechanized equipment. It tends to be more motor manual. Falling off in workforce, closure of paper mills as well. You can see that sort of dip there, sort of down towards a sort of a base there around sort of 2005-06. So the hardwood sort of forestry sector is not delivering what it potentially could. It could do an awful lot more, but where's that material going to go? So if you've got your eye on some of these markets like biochar, the hardwood timber resource is something that's probably worth having a serious look at. And then this comes to the bigger structural problem. This is the tree planting rates that we've seen in the UK over the similar sort of period, actually over the last sort of nearly 50 years. We have not really planted enough trees to keep up with our demand, and we certainly, because trees take a little bit longer to grow than miscanthus, this is not something we can just kind of turn a tap on and expect loads of new trees to sort of appear in the ground. So our tree planting rates have been really, really low. The Scots have been by far the most successful, and England and Wales have been really, really poor in terms of achieving new hectares of established forest. And more importantly, arguably, the types of forests that have been established are not the types of forests that are particularly useful from a commercial perspective. We're not, hopefully we've moved away, we have moved away in commercial forestry from the time when somebody would get a map out and a ruler and draw a big square block and say, right, we're going to fill that with Sitka spruce and larch. We've moved away from that. Multi-purpose forestry, well-designed, lots of open space, riparian planting as part of the mix as well. We've moved on from that kind of forestry, but it's swung far too far the other way to everything. It's all about squirrel habitat and rewilding and all the rest of it. So we're not really been expanding our area of commercial forestry to any great extent. A number of reasons for that. Lots of people now, I don't know, it's kind of mobilized by social media or just changes in society generally. Lots more people get interested in somebody wanting to plant trees. What kind of trees are they? Where are they going to go? Is it going to get in the way of my favourite view? Foresters now deal a lot more with people. We were part of the consortium that did last year's forestry workforce training, skills and employment assessment. And a lot of the conversations we were having with foresters and forestry businesses where they just couldn't recruit the staff. And the staff they could recruit wanted to do it because they were foresters, they were scientific, they didn't really like people, they wanted to go and work in the woods on their own and measure trees and all the rest of it. But what actually was needed for forest establishment was much more people skills, softer skills, engagement, all this kind of stuff that would get people over those hurdles. So there is a natural break on farmers being able to plant trees. A lot of them just go, it's too difficult. I'm not going to bother. I'm going to do something else. Well, heard of these guys? Brewdog's Lost Forest. Lost in that they're sort of promising to plant trees, but I don't think they've actually planted any yet. There's a documentary on it. This is all about carbon offsetting. Big arguments now around green lairds. I'm going to put these up so you can read them. Public money being sucked in for tree planting projects as part of this sort of medieval Catholic indulgences market that we have around carbon offsets. I'm going to plant some trees, therefore I can get away with burning fossil fuels for a bit longer, or these bad behaviours that we don't want to see. A lot of that sort of thing is going on, and that's driving things. If you dip into sort of Scottish land use and sort of Scottish community kind of sort of issues and some of the sort of Twitter interesting people to follow. Magnus Davison's a really good one, teaches at UHI. It's almost leading to another sort of set of depopulation of the highlands, because it's all about, we're going to rewild this. It's not for people anymore. We're just going to cover it in native trees and leave it for the kind of squirrel and the deer to do. It's not about commercial forestry. And that's pushing up land values. Some estate values have doubled in the Scottish Highlands in the last few years on the back of people land banking, and then people investing as corporate investors, as companies like Brewdog and Angus Poulsen, I think the chap is, who owns ASOS. He's now Scotland's second largest landowner, and he's just going to rewild a huge chunk of the Highlands and just leave it alone. It's not going to deliver any meaningful economic benefit. It's certainly not designed to deliver timber and biomass feedstocks into markets. So all sorts of things that forestry can and does do, and the pendulum has swung away from actually being able to do a lot of that stuff with an economic outcome in mind. A lot of it's gone far too far with a loud voice. We were talking about it last night in the bar around the sort of voices that some of the pressure groups have, and to some of the more vocal and problematic ones that probably feature in the Guardian article. You can add organisations like the RSPB, I'm going to name them. You can discuss whether or not it was a wise idea, but I've decided to do it. And organisations even like the Woodland Trust, who you'd think would be a good organisation around encouraging tree planting, not actually encouraging the right kind of tree planting. It's all about stuff for the squirrels and for landscape. So there is a skim across the top of a £2 billion industry in the UK. The pressure's coming from both sides. So thank you very much for listening.
So thank you very much, Neil, for giving us that perspective, both from forestry and from that sort of industry and very much the sort of policy piece. So the final talk, which is I think the shorter one, which is going to be from Rebecca, who's going to particularly give us an update from the workshop. Well, update some of the talk about some of the sort of outcomes from that. So
I'll work this one out now. How do I run through my... Aha, that'll be one. Upside down, that's why. So I'm going to talk a little bit. So along with the amazing team at Supergen, which they are, we held a workshop on land use decision making for perennial biology crops in January. So there's the names of the people who are going to help. I'm just going to talk about the social aspects, which feeds in quite nicely from the talk we've just had. So we held this workshop in January. We had 74 attendees online, I should say, from a mix of industry, academia, ourselves, obviously, government, as well as some of the NGOs and research councils. Within this workshop, we asked them 3 questions. We were asking about what the criteria should be for where we should put these bioenergy crops on our land. What is suitable land for bioenergy crops? What are those criteria? What the barriers are for sustainable growth of this sector, and also what tools were needed. So what modelling tools or land use decision-making tools were needed. The full report, which we've written up, is online, including everybody's little comments, not named. We've also broken them down into sort of clusters and groups by who said what, so whether it was an academic that was making comments in what areas. So if you want the full report with all of the stuff in, please go to the website. We took a long time writing it up, so it'd be good if you guys could have a look at it. When it comes to, but today I'm just going to focus on the social bits of this. So the bits where not the things around the economic criteria, not the things around the other aspects, but the things that people said that was more about the social aspects. So following on actually quite nice from what we've just been discussing. So in terms of the criteria, so these came in the sort of social criteria, there were the kind of things that we do relatively well in the modelling, or are picked up in some of the modelling work. So the food system interactions, visual landscape, local wealth. When it comes to looking at land availability or criteria for the thing, we kind of scoop those up in some of the modelling work we do now. Some of the ones we don't do so well, I don't think, are the community value of the land and the local cultural history, also the cultural value. So what I mean by that, I've pulled out some of the comments that people made. So when we talk about community value of the land, that's things like the leisure value of the land, access to the land, how the local community is using that land. So we need to factor that in if we're thinking whether a piece of land is suitable for bioenergy crop deployment or not, because it's going to change that cultural land. And somebody suggested it might be nice to have some sort of social index that we could overlay on our maps to work out where those bits of land are, how heavily are they being used. The other one was the culture. It's more like a sense of place, which I don't think we think of in the same things. This idea that the land that you're around, that you're surrounded by, is part of your identity. And the idea that actually in some ways this might be negative. So if people used to living in a very agricultural landscape, they might see bioenergy crops as a negative change. But there's also an idea it might actually not always be negative. So some point out that if historically the lands had a history of being used for fibre production, like hemp or flax, there's a much better chance that that society or those farmers or that community is going to be accepting of a bioenergy crop because they're used to this idea that land is used for fibre, than if you've got a culture. This sort of cultural history I don't think we scoop up. The other one that came up quite a bit was this definition of marginal land. Now, we as academics and I think policymakers use it quite a lot, and we've probably got a relatively clear idea in our head of what that is, but it's probably not necessarily the same idea as the person sat next to us. And there was an idea that this actual definition cannot actually be overly helpful. So it changes a lot, was the point that was made. It's done from perspective. So depending on who you are, depends on whether you see land as marginal or an important wildlife habitat, or maybe if you see it as a marginal land or somewhere you really like to walk your dog. So there is a difference between that marginality, and we need to be really careful when we're using that term. The other one that's pointed out is that some farmers find it incredibly insulting for their land to be referred to as marginal. So they don't see their land as marginal. They might see it as less productive, but they find that an insulting term. They're not going to plant a bioenergy crop because it marks them as having poor quality marginal land, and they don't want that marker associated with their farm. So what we probably should be using, especially when we're talking to people outside of maybe our own fields, is this idea of land being suitable for bioenergy cropping. It's not because it's marginal, it's because it's the best place to put the bioenergy crop with all those other criteria in mind. There were obviously all the economic criteria in here, things like transport distances, whether or not the crop's competitive, but these are the social criteria I'm talking about today. So the barriers, again, the things we tend to pick up on, these are the sort of, there's all the barriers we're used to, like the crop's got a competitive thing, but these were the people ones. So the one that we pointed out was the communication barrier and need for partnership were the two, I think, that really came up. The cultural barriers we've talked about before, about farmers not necessarily seeing themselves as a non-food grower. And we are kind of aware of those, but I think some of these communication issues maybe we're not. So it's pointed out to us we're not actually very good at telling the bioenergy story as a general community. And actually, when it comes to complex issues like carbon cycling, we need to get better at having a clear, consistent message that we can all get our language around, and that's policymakers, the industry, and people like Supergen and academia together. We're working on this. You'll see some of this tomorrow. There's some animations we've been doing exactly dealing with this issue to kind of demystify this complex system and do it in a much better way. So we do have a policy fellow in Supergen who does this a lot and very well. So that is a definite need. There was also a need for partnership, this idea of more intermediaries, and also the bit of them and us with the NGOs. That comment goes on to be a little bit more inflammatory than what's written there, so I've trimmed a bit. But this idea that it's been them and us for too long, this idea that either you're for or against bioenergy and there's no middle ground, and the NGOs sort of taking a position, and maybe we need to look at these intermediaries. There's also intermediaries for people sitting between industry and farmers, so some independent bodies where they can go and get information. And there are projects underway that Jeanette's involved in to look at putting in that sort of independent verification for farmers, somewhere they can go to get independent information that's not been given by the industry, but isn't being done in an overly academic way, because that's not what they want. They want, something that's usable for them. So the other one we looked, so the decision support tools. So this is things like modelling tools, like where should I put my bioenergy crop for policymakers, for farmers, and for academics. So the stuff that you've all seen earlier today. So the stuff that came up, as well as the social aspects of the stuff we're used to, the functionality and the accessibility. Are we making the models do what people need them to do, and are they accessible? But the one thing that came up a lot was this idea that we really need to be better at collaboratively developing our models. So this literally means we need a dialogue before, as we're making the models, with the stakeholders we're making them for, to ask them what they need so they can give us feedback. And so we can explain some of the nuances and generalizations that models generally have to have, so that people understand what the model is actually telling them in a much more informed way. There's an idea that actually a lot of the time modelling can be constrained about the data we have available to us. So things like soil maps may not be that accurate, and we use them as underpinning our model. So could we have an opportunity to actually get feedback from farmers on what their soil is, how their crops perform. And can we make those models two-way, or those tools, may not be models, might be apps, two-way, so we can have a feedback going on. There's also a point about this, when we're talking about collaborative development, we have to remember that every time we're making models or tools or making recommendations, we are making judgments based on our own personal status of what we think is good and bad. And that judgment is based on our own perspective, and we need to understand that whether or not different people are going to judge things differently. A farmer's going to have a different set of values and a different set of judgments than the community is. And we need to think about that judgment when we're developing our models and tools to make sure they are as effective as we possibly can get them to be. So this was going to be the quick talk, so I have done it quick. So in conclusion, the perennial biomass crops, the economics and the policy frameworks are key for getting these crops in the ground. I've not talked about them. They were some of the most important things in this workshop as a whole. However, they're not the complete story. If we don't pick up the social aspects, it's the farmers that are going to plant the crops and the community that's going to, and the voters who are going to get the policymakers to back it, and the communities who are going to think. So we have to be aware that it's not just about the economics. Cultural identity and social values will influence field-scale decision-making and the acceptability of land use change. And that collaborative, two-way, effective communication will be the way that we're going to get effective tools that do what we need them to do. So I think that's it. And then, yeah, that's me, and that's the link to the hub, so you can go and find the big report. Have we got time to finish?
So thanks very much, Rebecca. So we started a little bit late, so I suggest we do just a bit of a sort of Q&A, sort of as a panel. So I don't know whether, Neil, you want to come up as well. And sort of take any questions. Sorry, ready? I think there's a roving mic. Brilliant. So we've got the roving mic. So, do we have any questions? I guess
just
on
a quick technical thing. So it's important that if you have a question, you use the mic. Otherwise, it won't be recorded. So even if you think like, oh, I can speak without mic, if I just do it, you won't be recorded. So you need to share one, and that is for questions, sorry.
Right. Yeah, so is Anita also there in the background? Flute. Yep, there, brilliant. Hello again, Anita. So, any questions at all, please? Or Patricia?
Biased question. Northern Ireland. I noted it appeared on the maps that Anita showed. It appeared on the maps that Naveed showed. And one of you said, oh, we can get really high yields in miscanthus. And the other said, no, we can't. It's awful. What's happening? Why are your models so different for Northern Ireland?
Right. So one thing which I think I haven't mentioned that the maps which I have showed it shows very high resolution, which is 67 hectares of, as in 1 pixel that shows 67 hectares, because the average farm size in Wales and in England, which is 48 and 87, so it makes an average of 87 hectares. So using that as a high resolution, I try to check what is in other sides. So using that, the whole process, I have noticed that there were some sort of outliers in my mapping. So after removing those outliers, I have identified that miscanthus can grow very well on that. But there is two bits which has to be checked. One is about the ground realities. And definitely there is a possibility that there are some sort of chances that the results which I am showing that can be wrong. But what I have said, that is a live type of modeling exercise. So I haven't got any type of yield data from Northern Ireland that can further improve that my results are really representative from Northern Ireland. I got from Scotland, I got from England and Wales. But for Northern Ireland, definitely there are some sort of data constraints from that, because there is a separate type of independent data portal, which has a lot of bugs in that I can't get. But yeah, there is a need for ground truthing for Northern Ireland. Yeah. So
Anita.
over to you, Anita.
Hi. What I would say between mine and Naveed's results are that we've been both using different versions of the same model that I maintain and develop. We've also been using way different databases and different calibrations. So the calibrations I used were from 4 sites across Europe to take into account different climates and different soils, and all on marginal lands and only on 3rd-year growth. So that is not a mature plant in temperate locations like the UK and Ireland. So it will give a conservative value. We know that Ireland, from lots of experiments by Clifton Brown, we know that it produces good yields of Miscanthus giganteus. I was using the very high yielding new hybrids, but the calibrations are very conservative, and it is from marginal land and 3rd-year growth. So it will not show super high yields from those type of calibrations. And what we really need are longer experiments with really well-established and mature crops to calibrate from. But we have been using different databases in the model, obviously, as well. Yeah. And don't forget that if I model something for a climate scenario of 2020 to 2030, there is a danger of higher temperatures and effects from climate change. Although I would say Ireland is a good place with plentiful water generally to grow crops.
All right. Yeah, no, thanks. So I think it's probably also emphasising the importance of having, I guess, the ground truthing data to basically test the models against as well. So obviously, in effect, you're starting with data that's being gathered, which is used to generate the models, but those models need to be tested back against as new data comes in. So that's definitely, I think, part of what we've been doing, and some of the work Naveed's been doing, where we've been specifically testing across different climates how does the model track against that. But I think you've identified one of those areas that probably there's more work needed on ground truthing. Yeah, and which probably comes back from there hasn't been enough data starting from Northern Ireland in the beginning, which may be part of that, and certainly from what Anita said. So, no, good question, and I guess highlighting the caution that's needed in using models and the need to ask those questions about how that data's come from. But I think, great. By me, lots of questions. So, Zoe, I think your hand was up marginally sooner.
Bro, thanks. So the question's for Neil about forestry. So obviously, having a mind for biodiversity is also important, and other ecosystem services on the landscape. Do you think that the future of is there a future of the UK actually increasing its forestry? And is that through new forest generation, or will it be through bringing forests back into sort of better management?
Am I live? Yeah, so there's 2 bits to that. One is bringing forestry back into better management. That's been a KPI of the Forestry Commission since not long after it was established. So there's a constant drive through all sorts of different programs to try and bring woodland back into better management, because a well-managed woodland has more light reaching the floor, so it's there's more ground fauna and flora. So that's a given that's happening. Big issues around sort of engaging farmers. We touched on that a couple of times in the talks this morning. Engaging farmers. Most farmers, I've been doing this sort of thing for 20 years. I would class them as accidental woodland owners. It's something that just happens to be there when they took the farm over from their father or when they bought it. And a lot of farmers view forests and woodlands as and woodlands in particular. Forests has a commercial value generally, so they're a bit more interested. But woodlands tend to be something that's an annoyance. It's, that ash tree fell over into my field and now I've got to shift it out of the way, but hey, I'll have some firewood, or, it snapped the wing mirror off my tractor. That's kind of how most farmers view woodlands. So it's an engagement issue. You go to the continent, most farmers are also foresters, and they do both. So there's a kind of that hurdle to particularly with sort of changes in sort of agricultural subsidies, and I've actually seen some land abandonment and farmers just been abandoned in Northumberland because it becomes because of the change in subsidy regime. It's become uneconomic to farm that land which is more suitable for trees and bioenergy crops. so it's happened. So that should free up some land. There's still a large chunk of our uplands which are sort of frozen in landowner ownership, which is, it's there for shooting grouse and things, but that's starting to change as well. So I think unlocking those uplands and planting them with trees is where it needs to happen, because it does need to happen. We have extraordinarily low tree cover compared to the rest of Europe, and that creates sort of brakes on our bioeconomy. It creates a requirement to rely on other countries. So we need to do both things. We need to manage what we've got, but most of that is crap. It's suitable for chopping boards, firewood, and wooden spoons. Once everyone's got a wooden spoon in the house, you kind of don't need any more, because metal spoons are generally better. So it's about getting the right sort of forestry in the right place. And your point around biodiversity, the UK Forest Standard means you cannot plant those serried rows of conifers that characterise a lot of the planting of the 60s and 70s and early 80s. So it has to be landscape sensitive, it has to have open space, it has to be good for biodiversity as well, but not good enough for the pressure groups who are the ones that tend to shout loudest in objection. So I hope that's picked up those points.
Thank you. And then there was a question over there.
Hi, Keith Simons, SH Energy. Neil, you mentioned there's going to be a shortage of wood pellets because of the war in Russia and Ukraine. Isn't that going to be really good for air quality?
Good for what? Sorry, good for
air quality.
Air quality. Well, it's certainly, I don't know. It depends what it's been displacing. Pellets are the cleanest burning fuel if the systems are designed right. And then what's the alternative?
Cleaner than natural gas, bio gas.
It's not cleaner than natural gas, but it's near enough net zero carbon in terms of its carbon emissions. So,
but it's a two-pronged issue. We need clean burning fuels for the air quality impact it's going to have in the locality, and of course bio. So taking the wood and then turning it into a biofuel, which of course there's a big effort in. Because I think we can't ignore air quality, because increasing the amount of biomass burning will seriously impact air quality. Yeah,
I would, if it's done badly, I would agree. If people are burning wet logs in stoves, that will put out 100 times more emissions per kilowatt of useful energy than it will, than a clean burning pellet stove. So of all the fuels, pellets are very, very clean. The UK has about 25,000 biomass appliances of a commercial nature, and domestic automated pellet boilers and commercial chip and pellet boilers. It makes a fraction of a percentage point contribution to particulate emissions compared to wood burning in domestic properties, in open fires, in poor quality stoves. So if it's done properly with a clean fuel like pellets, it's losing all the pellets from the UK heating scene at the moment would make absolutely no difference at all to air quality.
There is data that with the catalytic converter and cleaner burning cars and diesel trucks, etc. That it's now becoming significant is the biomass burning in terms of air quality.
Yeah, that is, and reiterate, wood burning stoves, open fires, garden chimneys, and people burning piles of sticks and wet leaves in their gardens. If you could not discern the additional particulate emissions that half a dozen wood pellet boilers per town, which is Northumberland has about 400 systems out of 230,000 houses, and the most sparsely populated, which is where I'm from, most sparsely populated county in England. You can't spot it. You can't spot it. You can't smell it. It makes no difference at all. Log burners, on the other hand, I've got two. If that's not done properly, that can have a massive impact on air quality. But yeah, what's the alternative? Electricity at £1 a kilowatt hour? I don't think many people are going to go for that.
Thank you. I think we had a question here at the front. Thanks. Actually, I don't know. There's something on that. I remember there was a Supergen meeting some time ago in Sheffield where there was a group at Strathclyde who were working on a technology actually I think was using plasma to try and actually reduce particulates coming from biomass. I don't know. It'd be interesting to know if that work came to anything. I don't know. If anybody does know, it'd be interesting to chat when we get to the coffee break. Yeah, on that would be useful to know. Sorry, Jess.
Hi, Jess from DEFRA. I've actually got loads of questions, but I'm just narrowing down to two, if that's okay. The first one was for Anita. I think I saw in one of the slides you put up that there is an assumption that miscanthus grown in the UK would lead to a loss of soil carbon, but then the second graph below it kind of said, but that's sort of counteracted if you then pair that with BECCS. So is the assumption that you can only get those kind of positive carbon savings if there is BECCS in the mix, and actually just an increase in miscanthus without that being the end market would lead to a kind of net loss of carbon? Is that, I may have just misinterpreted the graph, but I'd be really interested to just clarify that. And then the second question is for Neil, and it was just a question about whether you see any role for short rotation forestry in the mix of future forestry policy, and how does that fit in with kind of other existing forestry creation policy and the kind of standards that you're talking about that have to be met. Thanks.
Okay, thank you. So,
Hi, Anita here. You make a very good point. When I show the results, I've aggregated them to show the potential per country. And that's a bit unfair for soil carbon, because higher organic soils really do decrease the good effect that, say, you can gain carbon in low carbon agricultural soils. So those have to be a balance, but distribution is everything. And of course, there are soil gains and losses, soil carbon gains and losses, and you just got to grow it in the right area. But an issue I think is, well, there aren't any rules around that. If there are incentives given to growers, they'll grow it on their land. So how much control do people really have on that? So I've given the aggregate value I had for the soils and the areas as a whole on the country. But the higher organic soils do affect that and bring the losses, increase the losses. And that was to show that some countries are really not so suitable, like, say, the Ukraine across Europe, that has very, very high organic soils.
Okay, so question around short rotation forestry, and does it have a role? Yes, is a short answer. Short rotation forestry will typically give you some sort of meaningful material within sort of 8 to 12 years. So when a farmer is deciding what to do with his land, he might decide that, yes, some miscanthus is for me, so you're getting a return on that relatively quickly. They might want to mix in a bit of SRC, and then you'll get your return within 4 years. And then something a bit longer term with short rotation forestry. The beauty of short rotation forestry is if you make the right species choice and look after them properly, you have an option to choose what to do with that tree. You could thin it out and just take some of that material and put that to an energy or another market, or you could allow it to grow on and turn it into construction timber. So it gives you options in the sort of the medium and longer term as well. And anything that's planted as short rotation forestry still has to meet forestry standards and take account of landscape and biodiversity and all the rest of it. So yeah, it definitely has a role to play. It's not particularly well understood, even by a lot of foresters, but it definitely has a role to play in bringing forward biomass for all possible markets in the medium and longer term.
Thank you. So, and actually, there's probably a number of us in the room, if you're interested in particularly the soil carbon story, where we could, from a UK perspective in terms of actual data, I think we could provide you with that. Was that any questions? No, yes, good. Okay, so Linda, so final question, and do we need to move on, or final question? One quick question, yeah.
Hi, Rebecca. I've got a quick question to yourself. I was interested about your observation about culture there, about farm and introducing about the growing hemp and what is the familiarity, because for some farmers, seeing a crop grown for 12, 15 years when they're actually sheep or livestock farmers, that is a cultural change. And I'm actually reflecting on a discussion I've had recently with a farmer who is expressing reflections of farmers who are a bit dubious about a crop, the miscanthus crop growing by a local landowner in North Wales. And I think there is a lot of discussions regarding communication there, because in my interpretation from that conversation was, maybe they have not much knowledge about the crop. It might be also they might be having a bit of issues with the landowner, And also one other question I also have, is there dynamics between the landowner and the potential tenants, because that is another complexity, and is that being addressed when in looking at resources? Or I know this could be a question for the next session tomorrow morning as well, but I think that dynamic needs to be explored because it has complexity as well in looking at the use of land and opportunities for biomass like miscanthus or willow.
Yeah, I think in short, you're right. That we know certainly for livestock farmers, they're one of the groups that a number of papers that have taken a sort of social scientist approach to biomass crop deployment have identified they're the group that are least likely to convert to bioenergy crops because of a cultural change in what they're growing. Because it's difficult enough to get an agricultural farmer to become a forester, or in my case, a bioenergy crop grower, to switch to something that's more permanent when you haven't got a yearly cycle, that you've got a long-term crop. When you're trying to convince someone who's sees themselves, identifies as a land, a livestock farmer to switch over to a crop, there's that cultural impact. The tenant farmer impact, I think I haven't looked recently, but there were some people that looked at. We know that tenant farmers may have issues on taking on long-term crops because of the fact they're a tenant farmer, therefore they're more restricted. I do think that is brought into some of the mapping opportunities, or can be brought into the mapping opportunities that Naveed need to do, because there is databases they can pull in to look at that sort of stuff. To a degree, it's got getting those updated. So yes, in the short answer, we do need to look at both those things. The information is key, and it's getting, I think, as more of these crops become visible in the landscape and farmers are talking to each other, that's how to get them to convert, because they won't necessarily believe us as scientists, because we don't have the right language a lot of the time to speak to them. So, short answers.
So, yeah, okay.
Just add one little bit to that. There are a couple of instances in Scotland where tenant farmers have been turned off their land for the establishment of carbon offset tree planting. So they've been quite well documented. So that's an issue for forestry in that sense as much as for bioenergy crops.
All right, thank you.